Welcome to Now You Got It! Today we are going to learn about the introduction to data structures. Now ready your ears and eyes on your screen. First, let's find out what are data structures. Data structures deals with the study of methods, techniques, and tools to structure data. They are used to organize data and perform data in the best way possible. The subject of data structures is intrinsically connected with the design and implementation of efficient algorithms. It means we use data structures depending on the data provided. The data structures are broadly classified as linear data structures and non-linear data structures. Okay, so now what is linear data structures? These are unidimensional structure and represent linear lists, like the example on the screen. On the other hand, non-linear data structures are two-dimensional representation of data lists, like the example on the screen. Now here is a figure that shows the kinds under the types of data structures. In linear data structures, we have two kinds, sequential and linked. Under linear structure is sequential, which includes arrays, stacks, queues, and priority queues. Array is an abstract data type, whose objects are sequence of elements of the same type, and the two operations performed on it are store and retrieve. Stack is an ordered list with the restriction that elements are added or deleted from only one end of the list, termed top of stack. The other end of the list, which lies inactive, is termed bottom of the stack. Queue is a linear list in which all insertions are made at one end of the list, known as rear or tail of the queue, and all deletions are made at the other end, known as front or head of the queue. It obeys the principle of first in, first out procedure, or first come, first serve. Priority queue is where an element with high priority is served before an element with low priority. Another under linear structure is linked, which includes linked lists, linked stacks, and linked queues. Linked list is a linear data structure in which the elements are not stored at contiguous memory locations. Linked stacks is also a linear list of elements commonly implemented as a single linked list but with two pointers. Linked queue includes two pointers maintained in the memory, that is front pointer and the rear pointer. Under nonlinear data structures includes trees and graphs. Tree is defined as a definite set of one or more nodes. Just for your information, a node in the definition of the tree represents an item of information, and the links between the nodes, termed as branches, represent an association between the items of information. Graph consists of a finite non-empty set of vertices, also called as points or nodes, and a finite set E of unordered pairs of distinct vertices called edges or arcs or links. Okay, now let's go to learn some additional information for this discussion. Why do we have to learn about data structures? Well, the importance of data structures is to store and organize data in an orderly manner. Using data structures, the user is allowed to access and modify the data efficiently. Also, we, the developers of a program, can know the step-by-step procedure on how to make a program or data. It is essential that the data on which the problems need to work on are appropriately structured to suit the needs of the problem, thereby contributing to the efficiency of the solution. How will choosing which data structure to use to help in creating efficient programs? The design of an efficient algorithm for the solution of the problem calls for the inclusion of appropriate data structures. It is very important to choose the most appropriate data structure for a certain problem to execute the program better. If a programmer or a developer chooses a bad data structure, the program will not perform well. There are different advantages depending on each data structure that can help the developer choose the most appropriate of a certain program. Which among the data structures highlighted in this course are you familiar with? According to your knowledge, how are they used or implemented in real life? As for the most commonly used, the familiar data structure is the queue, where it obeys the principle of first in first out procedure, or first come first serve. In real life, queues are seen whenever there is a line of people waiting their turn to be attended to. An example of this is the fast food chain. The first person in line will take the order first and is also the first one who will receive the order. Another example is a queue of customers in a hotel awaiting to be served by a clerk in a booking counter. Given a specific problem, which data structure should you use to be able to solve the problem efficiently? For example, there are given random numbers, then you should arrange it in correct position. This kind of problem must use an array data structure because this array data structure may help to arrange things in particular order. For queue data structure, when a resource is shared among multiple consumers, examples include CPU scheduling, disk scheduling. Now let's see your background knowledge about data structures. Are you familiar with these data structures? Which one? For your answer, please comment down below. This is the end of our discussion and I hope that now you got it! Thank you for listening, and if this video is helpful to you, don't forget to hit like and subscribe.